So I'm very glad to give my small talk on my small topics, and especially it's a good opportunity to share my research, our awesome work team, and it's my attempt tonight to show our work, and especially we will show some progress and the next plan. So if you have any questions, to please ask me tonight, or with a microphone later, or just email the message to my email address there. Here I put my email address here, and this work is financially supported from your university, and the grants to David Evans, and my other co-author is collaborator is Russ Anderson. He's a PhD student and graduate after that. He worked in Oxford, and the last one is Phil Merksland. He's from Canada. So my title is Uncovered to cover the late Ediacaran academics of the Avalonia terrane. Maybe some people don't like the word terrane, so it's just used as usual as the other people use. The terrane means blocks. There's no other means. Okay, my presentation is including the outlines. The first part is the motivations why we did the research on the Newfoundland of the Avalonia terrane. And the next part, I will show some preliminary study on the late Ediacaran stretch for the first stage. And the next, I will discuss for this time what we did and what we found. And for the last part, I will share our next work plan. Maybe, so especially for this part, I need maybe some good suggestions from you. So at the beginning, I want to show many awesome papers show that there's supercontinental cyclicity. And especially from the zircon age spectrum, and the circles or the signal of the supercontinent. Either it's longer or it's smaller or bigger. The cycles we can see that also including the hafnium isotopes and the deposits and the passive margins to show that there's a supercontinental cyclicity. And so what's the problem is the gamma now and the Panacea is gamma lines and all Panacea hypotheses. Yeah, because based on this study, David X have shown that every 6 plus or minus 100 MA there should be a supercontinent from at least since the Proterozoic to the Phanerozoic until to the future, maybe about 250 years later. So the only problem is that the Panacea, the amalgamation of the east gamma with the west gamma and the Laurentia. So especially from the previous slide, I showed there's no signal for the Panacea. So whether this supercontinental hypothesis exists, so we will do that. That's the first question, and especially after that, and especially after the early Cambrian. The gamma has assembled, and so we know that especially the gamma movement has good relationship with the biologic changes through the true polar wonder. So, but in the in between, there's no cancers on the gamma's precedence configuration during the Ediacaran time. So for many, especially for the most published papers, there always show that two alternative ring construction after the initial rifting of Epictetus' opinion. Related, this opinion related to the 650 MA long RD text. So here is the Zheng Xiangli's model. Here is the Sergei Peresovsky. So every time, because you have to show, yeah, because there are lots of uncertainties. So you can see that, especially for the Laurentia, yeah, because almost the continent reconstructions around the Laurentia to meet the positions. So you have two alternatives. One is long latitude, high latitude, higher latitude, and it's low latitude. So that's a problem. So there's no consistency on the Gamma configuration during the Ediacaran. And especially one of the main controversies occurred in the west region of this in the west region of this this land we call the Governor land. Here I use the map of the Rennet. Here's West Governor, in the center is the Central Governor, in the east we call it East Governor. The plus one, West Governor has been weighted together before at least 600 MA, and that means that this ocean has been totally closed before 6 MA. Or the second, there's another idea said that, okay, West Governor was not clear with the Central Governor after an ocean. That means ocean, and there's an origin we call Pampin, Paraguay. So that means during this during Ediacaran, whether there's an ocean between Amazon and the Central Governor. And another general problem is Ediacaran magnetic field mystery. Yeah, and it's including the high quality. There's no lack high quality people from Amazon. And one of the reasons is that at this area the magnetic field is very weak. So sometimes it's super high rates of reversals. And another is here the review paper by these people, I don't know what's the name, said that unfortunately paleomagnetic data between 900 and 600 MA are rare for all Governor craton blocks. So makes including the cratons of Amazon. So if we can deal the problem the reconstruction of Gamma during the Ediacaran time, it will deal with the first puzzle, the panacea, whether the panacea hypothesis exists, whether there's a supercontinent during between the Rodinia and the Pangaea. And the second means is if we can do a good reconstruction, we can see the paleography and a sampling of the West Governor, and of course including the whole view on the configuration of the Governor land. So yeah, because our Amazonia is not easy to get high, have to choose another ones, whether we can find another place. So fortunately, Brandon Murphy and these two people have to, and also including another people have well documented that Avalonia, one of the largest important information and on the supercontinental transition from Rodian to Pangaea. For the Governor, and especially Sergei Pisarevsky have made a good try for the pyramid on the west of Avalonia in Canada. They did get good pyramid data for the first try for the reconstruction, but they don't have enough data to calculate the pyramid pools and to see whether how the terrain movements and also how to relate it to the assembly of the West Governor. So that's why we did a pyramid on this terrain. So go to the next part. We did the pyramid study on the late Ediacaran strata for the second time based on the previous study of Sergei. So our study section located in the Newfoundland, close the, here is the star, means the location of our study area. Here is the looking, you can see here is on here the pink and the yellow color means the sampling set. So in the right, I show the column, the stratigraphy column, and in the center we can see the geology map. The stars also means the sets, and the white stars means the sets, sampling sets of Sergei. So our pyramid study is sampling, including the borearm formation, big head formation, rock harbor, and we did the pyramid sampling from the bottom to the top, and especially this strat have been well constrained by the new age. So here is the sections we collect sample from at least 5 sections, and also there's including the strata, including the Gascar glaciation. Here is some photos for the for the field work, and you can see our David is point to the conglomerate test for the rock and harbor sims, rock harbor formation in the between. So here is I show the photos what we did, where we do the experiments. All the samples we cut into these cylinder samples and do the demagnation in the at Yale University and use the rapid system. So the next I will show the represented samples behavior of the demagnation for the first for the borearm, for the bottom, for the about 590 MA. We can see the one stable direction, and for the almost one stable direction for the borearms. And here is a big head, and okay, I'm sorry, there some Chinese characters, and especially in the beginning, in the between the big head formation, we don't get the stable direction. And for the rock harbor, we get the stable direction, but we have to do the test, the field test, to tell us whether it's reliable or not. So for the top of the Crown Hill formation, and here we can see some samples show one stable direction, and the other ones show 2 components, and especially they can show the reversals. And here I will show the first in the left. I will show the stratigraphy, and in the center I will show the directions. The pink means the direction from Crown Hill, and the blue ones means the direction from borearms. And in the between Big Head and Rocky Harbor. Yeah, because for the Rocky Harbor, we did a conglomerate test. And B1 and B2, we drilled from the same conglomerate class. That means they should have the same direction, but they didn't show the same direction. So that means this the direction from the class is not uniform, and means whether it's stable or not, we don't know. So we just say, okay, for the Rocky Harbor, the blue one, the conglomerate test for the Rocky Harbor, the direction is inconclusive. So we didn't use the data for the further discussion. And for the Big Head, we just now we show that there's no any stable direction we obtained. So we only obtained 2 formations. The stable from 2 formations is from the bottom borearm formation. One is from the Crown Hill formation, and the blue ones means the borearm. Here's the first. The left is reversal test, and from A to B, the reversal test plus the full test, and the bottom is shows whether it's become more groups. So that means all of them pass the direction from the borearm and the Crown Hill passed the full test and reversal test, and especially for the borearm, the circuit sampled from another place, and they also show 2 separate conglomerate tests. So in this way, we think that we see that the direction, the parallel direction from borearm formation is reliable, and the direction for the Crown Hill reliable, and for the 2 formations in between, one is no stable, one is otherwise the direction is inconclusive. Whether it represents the age of their formation, we don't know. So we only use these 2 to calculate 2 poles for the at the beginning, and especially use for the borearm, the abbreviations we call BAB. Yeah, because another place, the surrogate sample we calculate the poles use BAA. So we use and the CH means Crown Hill formation. So for this one, we just use the poles to restart a composite Avalonia and set up a segment of the APWT from about 590 to 560. So that's why we put together, and also put the East Avalonia and the rest of the Avalonia in northeast USA. We put together to restore, to make sure the Avalonia is a whole block in this time. And to B, and we show that there's almost 90 degrees variation polar motion from about 590 to 560. That means the polar motion rate is almost between 2 and 9 degrees. It's very fast, and also the variation, the degree of the polar winter is about 90 degrees, only 2 time scale. So there are 4 possibilities for that relative to the West Africa, and also West Africa has been at this time, the West Africa also represented the central governor. So so in this way, there should be 4 possibilities, the relative positions between them. But this this figure is in the Africa coordinates. So if we put 2, 3, 4, is a little, yeah, because we know the Avalonia have to collide with the governor land at during the Paleozoic time. So it's not easy to explain. They will come around to the South Polar area because we know, especially for the governor land time, the main governor land time, the governor is in the South Pole. So if 2, 3, 4, the position is right, the positions are right, it's hard to explain. And for Avalonia to come together with a governor land. So for this way, we choose the position 1 is the best one and the suitable one, so that they can come to a short cut to come together with a governor land. So we choose the first one. The position 1 is the best one, suitable one. Okay. So for that one, so whether we can use the we can match the APWP between the Avalonia and the central governor and another place. And especially there are another possibilities for the especially during between the 650 to 550 MA. There are 2 great ideas. One is the equatorial dipole model. That means just choose the dipole model 90 degrees, very different from our current dipole model. And the other proposition is like that, is true polar wonder. So weather is suitable for the reconstruction. And because we have to use APW match for the reconstruction. So if we use purely on the reliability rather than a pretty judgment, pretty tectonic judgment implications. The first we did, we got that for Laurentia, the multiple component directions, especially for the Greenville decks. Yeah, because why? There are 2 alternative models for the governor reconstruction. And one of the main reason is that the same rock units, the direction from same unit rock unit have two directions, one steep, one shallow. And they always, the different people say, okay, this is equally reliable. But if you use the same standard to select the directions, we show that the multiple directions from the same rock units are not equally reliable. And the second one, for the West Africa, for the high quality poles, and Laurentia and Baltica, and including this our new poles from Avalonia, they will share a similar polar variation over the same time interval. So in this way, we can compare the APW from each other, and we can show that especially the the same interval from 590 to 5, there's some offset of the time scale. 590, our time is 590, but in the from Africa, there's about 575, maybe there's age some uncertainty. And for this area, the age is very similar. Another problem is that here is the flow. That means if there's a big polar wonder caused by the plate tectonics, That means that this Laurentia, this the continent should be far from the plume. But if they always come together, but for the big polar wonder, that means maybe the true polar wonder is perfect, is preferred. So we use the true polar wonder from 590, 575 to 560 to use this frame for the reconstruction. Okay, so use the true polar wonder. So and of course the actual dipole model is maybe some permissible, but the more evidence to prove the weights to the true polar wonder. For A, it's in the Africa coordinates. If because some people propose that the Avalonia should be connected to Baltica, and some people, especially many previous studies, show the Avalonia should be around here. Yeah, because if Amazon has been connected with the West Africa, and the Avalonia should be here. But if we use this area, we can see the poles from Avalonia, the green one, there's a big offset between the other poles groups. This one here is 590. About that, you can see the big offset. So that means X position is not good. If the Avalonia connect to Baltica, but Baltic, yeah, because especially in after the final governor assembly, the Avalonia should be around here. That means here is if we move all the 590 to 570 poles to around the South Pole for the reconstruction. That means the Avalonia should have go around. Okay, sorry. Go around to this area and then go up to connect the Amazon. So it's very hard for the Avalonia movement. So this one is not good. So for the C, we choose Avalonia and Baltic. So Avalonia connect to the Amazon, and the Baltic is next, not far from these two. Yeah, to match the APWP is good match. If the C is in the Africa coordinates, if we move to the South Poles, South Polar, the reconstruction can reach in this area. For the labs, we just show the overlaps of the poles. For the reds, we just show the reconstruction. In this area, the Amazon is connected to the Avalonia, and in the center, there's a big gap between the Amazon and the central governor. That means at this time, we use at this time, the Amazon is not come together to the central governor. That means the governor is not finally assembling at this time, and they are separated by a wide ocean. They have given the name Calamity Ocean. That means also there's no existence of the Pannonia supercontinent. And the second that means our study also support that the final assembly of governor not until happened after happened until early Cambrian. So this is our first stage and the outcome of the first stage. For the further work, I plan to do the same thing on the lower strata. We did the upper ones from a boream to the crown hill. For the next plan, we have to do the same thing for the connecting point group. Yeah, because there's new age, good age for the constraint has been published. We want to do the following purpose. More data for the test of the 650 to 590 true bonder. Yeah, because we see the two big waves. We test that we have documented the true bonder from after 90 MA. But how about the the older ones? The second one, we want to take to understand the tectonic evolution of Avalonia Amazon in the earlier Ediacaran and the knowledge on the opening Epictetus Ocean, because there's a new paper, this great paper said, okay, there's another log of the thesis opening of the Epictetus Ocean, whether it's red, and this hypothesis need to be quantitative test. And the third one, especially to understand the relationship between the rapid rise and down of the Ediacaran life and the possible true polar wonder, if it happened. So for the next plan, the second, because many people say, especially here is a Jumert's paper said, okay, during this time we can see the magnetic field intensity is very low, and also we can see the high super reversals, but how fast we don't know. So for the first time we have to do the metric stratigraphy for a continuous section from the crown hill, because there's no direction. The section is continuous. We will sample that, and we did a lot. And this is the next the plan for the next work. So my sharing is all. So welcome any suggestions. And I want to improve my work for the next stage. I don't know whether it's right, or do you have any very different or new perspective ideas? Please do me, and questions are also welcomed. Thank you for your attention.